how do you have so many buses? Okay, that's number one. Second is what's happening inside Samsung's semiconductor center?
We are always hiring. What is our goal?
Yeah.
I think we are pretty good at it.
One question that I have, Rajesh, like, how do you have so many buses? Okay, that's number one. Second is what's happening inside, Samsung's semiconductor center that needs this scale of movement every single day?
Okay. Namaskara. Thank you for having me.
Yeah.
Right. So I'm sure you didn't mean why you have so many buses.
Yeah, not semiconductor wise, but yeah, literally in the.
So I think we have a lot of employees. Most of them are very young.
Got it.
They normally tend to stay in and around our office. So,
Got it.
And I think having a bus makes it a little bit easier.
Got
So
it.
I think our motivation is don't worry about transport, food, etc. You just think
Got it.
about what you will do at work. So the rest of the things about what I'll do for eating, how do I get to office, you don't need to worry about it, right? So that's the motivation behind providing some of these facilities. So you don't have to, worry about them, and you can come and be your best avatar of yourself. So that's why you see. And I think you see so many buses because it's not just semiconductors.
Correct.
The mobile division buses are also there.
Okay.
they also look the same. So
Got it.
we are sister companies. So that's probably why you see there are there are a lot of employees across both organizations.
Got it. And what is happening inside Samsung, semiconductor center there? And why do you see this so much scale? I think you came in, Bangalore got established in 2006, and you were part of Samsung in 2004, where you were part of the mobile division. I want to understand that entire scale and the talent aspect here in Bangalore. So 2006 is when you guys set up, versus now. I think you have more than 3,000 plus employees here.
True.
Yeah, it's a huge thing, and that also tells why there are so many buses as well. And also that is a huge talent. You have molded this company, the R&D center here, from scratch. You have built the team from literally from scratch to what it is now. From 2006 to 2025 we are in. What changed, Rajesh?
So maybe quick flashback. So when I joined Samsung, I joined
Correct.
as part of the mobile division.
Correct, yeah.
So at that time, we didn't have memory.
Yes.
We were part of one big Samsung team.
Correct.
And I think the primary reason, so I joined Samsung Mobile for a couple of years, did 3G in the US, and then memory wanted to open a setup in Bangalore.
Correct.
I think the reason at that time was India is known for software.
Correct.
Everybody is in India. The mobile division guys seem to be doing well, so we should also invest.
Correct.
And coincidentally, at that point, I think the storage market was also evolving from a pure hardware business to hardware plus software.
Correct.
So I thought it made sense at the time. Come to India, there is a lot of software. That's how we started.
Correct.
In fact, when I started memory, I didn't start the semiconductor per se. I started the memory division.
Correct.
Most of the initial work was on software.
Got it.
Work on Linux, open source, device drivers, Windows Mobile, Symbian, all that stuff which were prevalent at that time. And then Android came, right? So that's how we started. But I think over a period of time, I think once Samsung and we started looking at what outcome and output can come from India, I think the expectation slowly changed into what more can Samsung do for the business.
Got it.
How can they impact our business? How can they make real products? I think that's how it started. So it was a very organic growth. Step by step, you did software. Okay, you're good in software. Can you do higher quality software? Can you do software which goes into products?
Correct.
I think that's been the evolution.
Correct.
And along with that, can you do the testing? So can you do temperature testing? Can you do AC/DC electrical characteristics in India?
Correct.
So slowly the labs also started building up.
Correct.
To compensate for this expectation. And along the way, I think what I realized was India is not just a software focused country. There's a lot of hardware talent.
Correct.
While compared to software, it is small.
Correct.
But I thought we had very good hardware talent. I think globally there are more software engineers than hardware.
Got it.
It's the same in India, but I think the volume of talent in India was quite good. So we started some hardware or pure chip design business or projects in India.
Got
So
it.
again, like software, we started small, but I think right now, if you see what we are doing, pretty much any product from memory which goes to market has a big footprint from India. Right? So it's not like I supported, it's like what we have coded, what we have developed is actually going to end customers.
Got it.
So I think that way there is a lot of pride
Got it.
in the employees. and I think that also allows us to retain a lot of the key people.
Correct.
Because they can see their actual projects
Correct.
being sold in the market, deployed in the world's best data centers, deployed in latest laptops and mobiles. I think it gives a lot of pride that you're working on cutting edge. I think that's been the combination:
Correct.
organic growth and work on projects which have high impact.
Correct.
And thereby build the trust and competence and move.
Got it.
I think off late I've taken charge of all of SSIR,
Correct.
which includes a few other businesses.
Correct.
Foundry, for example, and SOC.
Correct.
Story is very similar there. It's not very different.
Okay.
The story is same. I think SOC has grown even more
Got it.
than memory, so they are probably much bigger than memory, almost double.
Correct. And I think what were some of the early bets, that you took chance, like in terms of talent, in terms of partnership, or that kind of scale you grew here in Bangalore, and more than 3,000, that's huge. So what were some of the learnings for you personally to scale at this level? And it can be advice to a lot of GCCs who are planning to now come to India with a different mindset. So you guys literally have been the OGs of setting up.
We've been here for a while.
Yes.
I think 2 or 3 things, right? And in my view, the first is I think basic intent and expectation that we do our best and we deliver the best. Don't compromise on quality.
Got it.
I think that's always been my motto. Like if you can do X, I think we should try for 2X or X plus plus, do something better.
Got it.
Don't stay at what you can reach, go beyond.
Correct.
I think in my view that brings passion, that brings a lot of trust.
Correct.
And belief in your ability.
Correct.
I think very often you work with your overseas partners or headquarters. When they see that, it changes. It's sort of how when a startup pitches to a venture.
Correct.
If they see the passion and that, I think they would have more commitment.
Correct.
So it's the same thing. I think if you have that feeling and passion to do well, I think good things happen. So I think one is, that's like hygiene for me.
Got it.
I think you keep doing that. Second is, I think we took a lot of bets in terms of jumping into projects or taking up responsibilities where we were not sure if we were ready.
Okay.
But if you miss the boat, then I think you're gone.
Got it.
So you have to get onto the bus whether you're ready or not.
Correct.
And then finish the job there.
Correct.
Quite a few were very risky.
Correct.
And in a couple of them, we didn't succeed on the first attempt.
Got it.
But I think that belief and the confidence from our partner that you are putting your best, I think allows us to jump over the hurdle.
Got it.
So the one is take a jump, be brave, take a risk. And I think if you have enough confidence, they will help you jump over the small hurdle. So they're not waiting for you to fail.
Got it.
They're looking for you to succeed.
Correct.
I think if that's the partnership mode,
Correct.
I think everything works well.
Got it.
So maybe, that was the second thing.
Correct.
Right? You take a bet and jump in even if you're not ready.
Correct.
And third is probably, maybe venture into the unknown.
Amazing.
For example, we started doing things which we didn't know how to do.
Got it.
So we went and pitched saying, hey, I would like to do this. I want to invest in this new technology. It's coming up, new spec, new standard.
Correct.
Or I don't know hardware, or I want to do layout. I can do it better than others. Today you're giving to somebody,
Correct.
right? And we don't have a team which does this.
Correct.
But looking at your ecosystem, that's Indian ecosystem, right?
Correct.
Or your neighbors in your own company, there is talent for certain type of work, and then maybe go pitch on that and see how that talent can do better than what's already happening.
Got it.
I think our motto is, if it's as good as what's already there, there's no point in doing.
Got it.
So, right. So if I'm trying to do something, it should be better than what's there.
Correct.
It should be better than status. That's what I can look back.
Damn.
And I think failure is part of the game.
Got it.
So if you hope to succeed everything you do, I think we are set for disappointment.
Makes
a
sense.
little bit resilience.
Correct.
That okay, things will not go your way all the while.
Correct.
Hold tight. Yeah. That
Makes sense.
That's my motto. Yeah.
Got it. And can you tell me some numbers, in terms of like building from India to the world, from the Samsung, what are some of the technologies that are going out to the rest of the world that you can, top of your mind, kind of remember? And also if there are any numbers, like how much, is it like all of the projects, it has become like a global hub for innovation for you guys from India is literally supplying to the world? Is that the story? Like,
So if you look at semiconductors, we call ourselves component suppliers.
Correct. Yeah.
Right? So the end users like you and I don't buy
Correct. Yeah.
semiconductor. We buy products which use components.
Correct. Yeah.
Right? So by definition, pretty much everything we do is for a global customer.
Got it.
There are global customers who have local arms.
Correct.
Because they manufacture in India, they have a factory here.
Correct.
So they source here across the globe, Asia and other
Correct,
places.
correct.
So we do support all of them.
Correct.
But I think the nature of our business is such, pretty much everything we do is for a global customer.
Amazing.
Right. And you asked about, are you the global innovation hub?
Yeah, like the...
Yes, but
yeah.
we're not the only one.
Correct.
I think it would be brutish to claim we are the only ones.
Like,
Rest of the world is not doing anything. Right?
Correct. I'm just thinking outside the Korea thing. Like I think Bangalore has emerged. I mean, the hub has emerged.
I think in terms of contribution to end product, I can safely say we contribute the most to products which go to market.
Correct.
But are we the only ones?
Correct.
No, there are other pockets. There are other R&D centers across the globe.
Correct.
And we have 3 businesses: memory, SoC, and foundry.
Correct.
Each of them have their own markets.
Correct.
Where they think their talent is, where they think their customers are. So each of them has their own R&D centers.
Correct.
So, and they have a certain expectation from each. I think India is the only one which has all 3 in one place.
Nice.
That's a bit unique for us.
Correct.
So it gives us a little bit of a leverage or advantage.
Got it.
But yeah, that's well.
Amazing, amazing. So Rajesh, moving on to AI in semiconductor, right? So it's a big topic.
Yes,
Everybody's talking about it. All companies are talking about. Leaders are talking about it. How it is changing, like right from design to memory to your foundry to almost how mobile devices or edge use cases are being unfolded, right? So now AI has percolated every aspect of it. I would like to have your thought on in terms of how it has changed, chip architecture, the usage of AI in that aspect, and in memory, and how was it passed? I mean, you have seen everything, seen it all in the industry. Then versus now, what has changed in the game? Like, is it accelerating at a much faster pace? If it is accelerating at a much faster pace, how much is it reducing the cost burden? What is the impact of the use of AI in all of these areas of semiconductor life cycle there?
So,
and that's a large question.
So I'm trying to figure out what's the best
top
way
it
to
up.
answer you.
Yeah, because it has to be simplified for our viewers. Like,
so if I look at AI in semiconductors, I can probably break it into 2 parts.
Amazing.
One is actual chip design itself.
Correct. Yeah.
And how AI is used for finally making that small black thing which goes into your stuff. Right. The other is what is the environment or the ecosystem doing with it. Whether it is on a mobile phone or on your server, ChatGPT is responding something, or on your car it's doing something fancy. So that's the application side.
Side, yeah.
So we won't go there a lot now for the sake of our discussion. I think use cases are obvious.
Yeah.
On your phones you can take pictures, do things.
Yes.
Like a lot of stuff, right? So maybe we can focus on the chip design.
Chip design, yeah.
Right. So how have things changed in the past? Again, there are 2 things. One is because of AI, and there's a lot of new requirements on the chips that we manufacture.
Got it.
Because the volume of data that is being consumed, the speed at which is being consumed is very important to give good results quickly.
Correct.
For example, if you go to a query agent and type, and if you have to wait for 10 minutes, you wouldn't go there. You want quick response.
Yes.
Which means, in the world of AI, processing a large amount of data very quickly.
Correct.
Right? So we have a lot of requirements on storage. You mentioned memory and storage. Where we want quicker access to a lot of data. And also very quick turnaround time. Like if I read some data, how quickly is it coming back? I think there are a lot of requirements which pose a technical challenge. So, and a lot of this has come in the last 3-4 years. So we were going slowly. And then somebody pressed the turbo button, like you said, F1, right? And then it's just taken off.
Correct.
And now requirements are coming thick and fast. Can you do this? Can you have more terabyte? Can I read 4 KB in one shot, 10 KB in one shot, 16? So there are a lot of requirements. Like, can I read it in half the time? Right? So there are a lot of requirements, and it is, and the industry needs it. Right? So it's a technical challenge for the teams working on it. So from an architecture perspective, a lot of what we see is people beginning to think on how can I support large density, quick latency, more throughput. Right? Throughput is like how many cars can go on the road. And latency, like how quickly are they going, so you can reach the end quickly. Right? So we have to look at both, and total volume of cars capacity. So we are looking at architectures which are cost effective. Power efficient, which can help us to create solutions which can be deployed in AI. Right, especially some of the edge items, they are battery powered. They're very sensitive to power. So what like what you plug onto a 220 volt expectation is different from what runs off a battery.
Got it.
So there are those things we need to consider.
Got it.
So from an industry expectation, there are all these things which are happening.
Correct.
Right? And then once you do the architecture design, it's a question of implementing it. So that's same as before.
Got it.
The other part of AI that's impacted us is how AI is impacting how we do our work.
Got it. Yeah.
Right?
Got
That
it.
is where a lot of fear of will AI replace us? How will it help me?
Yeah.
Right? A lot of unsaid questions are there.
Correct.
Our view, or my personal view, is it's going to be a strong tool
Correct.
for you to do better than before,
Correct.
faster than before, develop
Amazing.
higher quality products.
Got it.
For example, if I had a product which was taking 10 months to do,
Correct.
maybe with the help of AI, I can do it in 8,
Wow.
maybe 9, maybe 7. So it probably reduces the amount of time it takes to get out. The quality of the products I expect is better. We can see proofs already.
Got it.
So that it can catch bugs which you earlier couldn't catch,
Correct.
which means the end product is of a higher quality,
Damn.
higher reliability, and so on. And I think that's primarily where we see
Got
the
it.
end impact. And it's not done yet.
Okay.
So the possibilities are there.
Got it.
So each company has to work with some AI framework
Got it.
and then see how to leverage it to your workflow.
Correct.
Every company has their own style
Correct.
of doing, like different people. All have cars, but every car is different, right? So
Correct.
there are nuances. So I think we need to take our LLMs and all these AI frameworks,
Correct.
tailor it to support our workflow.
Correct. Correct.
And we are doing that as we speak on each of this design
Very
part,
interesting.
testing part, layout part,
Correct.
post silicon. Once the chip comes back, how do you test?
Correct.
And I think once we figure things out,
Correct.
I think it will become part of your everyday life. So it is
Understood.
sort of like how when we taught everybody C programming, then
Correct.
knowing C was not the differentiator.
Correct.
It became a basic.
Correct. Correct.
Right? Knowing C, you could code faster, finish faster.
Correct. Correct.
But the work didn't stop. You just had to do more work now.
Amazing.
So my assumption is as we go forward,
Correct.
we will start making more products.
Correct.
We can't do that today. We don't have the ability.
Correct.
We can't
correct.
scale.
Correct. Correct.
So maybe with this help, we can do more products which are better
Got
and
it.
faster.
And just a quick question on the, I mean, I know it's a little futuristic, on the networking side. So I think Samsung has been instrumental in building the RAN systems that, I don't know what you call now.
Radio access network.
Radio access network. So now it's changing towards 6G and all of that. So there, I'm hearing a lot of things on how AI is being integrated in the network layer kind of a thing as well. So what a fascinating thing that as a leader who has worked on a 3G system versus on 6G, what is changing there on the networking front? I mean, I know they're calling it AI RAN now. It's like
True.
Yeah,
So
it's a very
I think you can add AI to everything now, right? So,
yeah.
so this comes under our mobile division.
Correct. Yeah.
Right. So there also, if you see, we have two components to networking.
Correct.
One is actual stuff which sits on your mobile.
Correct.
Right, which makes a call. There is an
Correct.
RF.
Yeah.
And there is the network side, which
Correct.
is what your network providers who give
Yeah.
your subscription. So there are, I think Samsung is one of the key contributors. 5G is, in my view, primarily it's like a huge bandwidth, much more download,
Much more
faster capability. But 6G comes with new features.
Correct.
For example, vehicle-to-vehicle protocols,
Got it.
short-range protocols. So what it means is that through that protocol, you can talk to a base station, which is like smart cities was a good example earlier.
Yes.
You would have small microscopic base
Correct,
stations
correct.
across. So the electric pole would know a car is passing.
Wow.
And it can tell you there's an accident up ahead, go left. So I think that's I think we can imagine what we want
Correct.
in terms of what are the end use cases. I think it's unlimited.
Absolutely. Yeah.
But I think the key idea is it's opening up a new level of communication,
Correct.
which is very short range,
Correct.
very real time,
Correct.
which also means you need a lot of edge computing, a lot of processing on the edge.
Correct.
So in your car, you need something which can decide on the fly.
Correct.
You can't wait to send it to the web, wait for the answer, right?
Absolutely. Yeah.
So there is some architectural what can be done here versus
Wow.
what can be done there.
Got it.
And the networking also supports some of those features.
Correct.
So which vehicle, which identity is moving where.
Correct.
So they provide a lot of these features as well.
So very interesting, very interesting. So now coming to I think we touched upon all the semiconductor life cycle. Even we didn't leave networking also. So just quick question on India's 3 nanometer future, right? So everybody's talking about this. What does this mean for India's role in next generation chip design? Like,
There are two parts to this.
Correct.
Right? So
Please,
one is the design part.
Yeah.
Right, which is what most of the companies in Bangalore do.
Correct.
Which is
And I think 20% of design talent is in India, if I'm not wrong. Like,
I'm guessing.
Yes. Yeah.
Growing continuously. Yes. So the one part is you make the design. Sort of we can look at it like an architect for your house who designs everything.
Correct.
And makes the blueprint.
Correct.
And then the rest is actually how you manufacture or fabricate.
Correct.
That's a fab.
Correct.
We don't have them in the same numbers in India.
Understood.
Right? So that's actual. So in the fab, take a design.
Correct.
And actually realize a chip.
Correct.
Which is running at 3 nanometer. You can pick whatever numbers you want.
Correct.
I think SCL is at 180. There is some new fabs which are coming at 28.
Correct.
Each of them are useful in their own way.
Correct.
It's not that it's old, it's not useful.
Correct.
Power electronics require older nodes because they can't handle miniaturization.
Correct.
Having said that, a lot of the expertise we build is in some sense independent of the fabrication methodology.
Understood.
So the inherent design doesn't change.
Correct.
Of the chip. What changes is finally when we finish the design, we implement it. We call design implementation. So there the constraints on you in terms of how you place the things, how you draw the wires between two people,
Correct.
what should be the clock frequency, etc. So there at 28 nanometer will have a certain different expectations compared to a 2 nanometer. 2 nanometer may have more leakage but low power, somebody may be more tolerant. So the fabs who do these 2 nanometer, 4, 6, 1, etc. They usually give us parameters.
Got it.
Hey, these are the constraints, so make sure when you do your implementation,
Correct.
you stay within these constraints.
Got it.
So that's usually where the 2, 3, 4 come into picture.
Okay.
To that extent, I think everybody in India should be able to work on 2 or 4. It's an extension of
Got it.
the same. It's the same game, slightly different parameters.
Got it.
Some are easy, some are tough, but
Got it. And now coming to the final, right? So India, like it has become a semiconductor hub now. Everybody's talking about it. Government is
real Silicon Valley.
Yeah, real Silicon Valley. Yeah, and I think government is also supporting in a large way. I just want to understand like the next decade. If next decade is India, I know it's already here. But what is like. What do you think we should get it right today to actually lead the way for becoming semiconductor hub in India and make it what should we do it right now? Like what do you think?
I think today we mostly have the design ecosystem.
Correct. Yeah.
Right, and which is very strong, very well regarded.
Correct.
I think US is also very similar.
Got it.
In the past, it had the whole ecosystem. It had the fab, everything.
Got it.
But I think it's also losing out in the race.
Okay.
So they're also now trying to invest, just like our government, which is also trying to invest to create the whole ecosystem where it is not just design, but we focus on the full life cycle.
Yes.
Where you do the design, you do the manufacturing. And then you do the ATMP, you do the packaging, post-silicon. Right? So we are trying to see if the whole ecosystem or life cycle is there.
Correct.
So in my view, having the whole ecosystem is key.
Correct.
I think in the keynote today I was sharing, ISA had shared that the government initiatives are now seeing fruit.
Correct. Yeah.
There are a lot of people who have already invested.
Correct.
I think almost 15 plus companies on the back end.
Correct.
So we still don't have the fab.
Correct.
In numbers, but once the chip comes, once the wafer comes, cutting the chips out, putting them together, bonding them, putting the lines out, testing them, all that is, we have investments there. So I think it's a step-by-step process. There are some fabs already. It is still a very viable, it's a commercially viable solution. It's not an R&D facility. You can make money out of it.
Yeah.
So I guess it's a good thing to start. You need the whole ecosystem. Otherwise, you make some and then you go somewhere else. And
makes sense.
That's my view. So that's one.
Yeah.
And maybe the other part is once you start having companies, Indian companies manufacture in India.
Nice.
Which is what I think a lot of the US companies have an advantage or China has.
Correct.
I think local companies will fuel this even more. We have a lot of demand.
Correct.
But not a lot of production per se. So the demand is high. India as a country has a high demand.
Correct.
But I believe that if companies come which are manufacturing here, producing this, consuming the outcome of the semiconductor chain, I think that would fuel it even more.
Damn.
That's what I think.
Very nice. Thank you for that, Rajesh. It was a very wonderful conversation. Just final thought. You're managing a huge team of 3,000 people here. So what's next for Samsung? Semiconductor India. Research in terms of. What's next for you guys? What are you planning in terms of expanding? Are you guys hiring and any kind of college collaborations and what does it take for someone to work at Samsung Semiconductor Center there?
Okay. Good people are always welcome. I think every company will tell you the same.
Yeah.
We are always hiring. What is our goal?
Yeah.
I think we are pretty good at execution.
Correct.
We have center of excellence in certain domains.
Correct.
What the next bar for us is maybe thought leadership.
Understood.
For example, are our employees well regarded globally?
Amazing.
Are they setting the benchmark in global standards?
Correct.
I think that's our next benchmark. I think doing is possible. Managing full products, not a problem.
Got it.
And I think now the time has come for us to actively influence how new architectures emerge, how new standards evolve.
Wow.
Right. So I think that's where we think we should go next.
Got it.
Not only as a company, as a country also. I think there are a lot of people in different companies who are at that level. I think we need more in numbers.
Got it.
I hope in Samsung we can provide some of those numbers as we go forward. And so that's our goal. Not necessarily grow in terms of scale, but grow in terms of impact and the value we can bring.
Amazing.
So that's at least my motto. And what does it take for somebody to come to work in Samsung? Maybe a lot of passion.
Got it.
And that's about it. Have a lot of passion to the work.
Got it.
And believe it can be done. And I think it's usually getting done.
Done, yeah. And I think the culture also is amazing. I was just talking to a few of the people from Samsung. Most of I think are staying here for more than 10 years, 5 years. It's like they've been part of the journey for a very long time. What is that one culture at Samsung that makes them stay for long?
I think I would like to think of it as a big startup. Amazing. Which means it's a lot of exciting, lot of new technology to work.
Correct.
I think that's what engineers like.
Correct.
Not I tell you what to do and you do and then you keep doing it forever.
Correct.
So I feel that's our USP.
Correct.
It's sort of like a startup under the umbrella of a very stable company.
Correct.
But the environment is very startup-ish. A lot of new tech, a lot of opportunity to look left, right. There are no real boundaries and that don't do this, don't do this. I think there's a level playing field for you to try a lot of things. I believe that's our USP.
Amazing. That's it, folks. That was Rajesh Krishnan, Senior Vice President and Managing Director at Samsung Semiconductor India Research. Thank you for your time. That was a wonderful conversation. And wishing you all the best. And may I see more buses in Bangalore and someday even metros, if possible. Yeah. Lovely meeting you.
Thank you very much.
Thank you so much.